refresh cathode ray tube, that is CRT. In this video, we are going to see about refresh cathode ray tube, that is CRT. A CRT is an evacuated glass tube. An electron gun at the rear of the tube produces a beam of electrons which is directed towards the front of the tube, that is screen. The inner side of the screen is coated with phosphorus substance which gives off light when it is stroked by electrons. It is possible to control the point at which the electron beam strikes the screen, and therefore the position of the dot upon the screen, by deflecting the electron beam. The beam is positioned on the screen by a deflection system of the cathode ray tube consists of two pairs of parallel plates referred to as the vertical and horizontal deflection plates. The intensity of the beam is controlled by the intensity signal on the control grid. The voltage applied to vertical plates controls the vertical deflection of the electron beam, and voltage applied to the horizontal deflection plates controls the horizontal deflection of the electron beam. CRT techniques. There are two techniques used for producing images on the CRT screen: vector scan or random scan. Raster scan. Vector scan or random scan. In this technique, the electron beam is directed only to the part of the screen where the picture is to be drawn, rather than scanning from left to right and top to bottom as in raster scan. It is also called vector display, stroke writing display, or calligraphic display. Picture definition is stored as a set of line drawing commands in an area of memory referred to as the refresh display file. To display a specified picture, the system cycles through the set of commands in the display file, drawing each component line in turn. After all the line drawing commands are processed, the system cycles back to the first line command in the list. Random scan displays are designed to draw all the component lines of a picture 30 to 60 times each second. Raster scan. In a raster scan system, the electron beam is swept across the screen one row at a time from top to bottom. As the electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. Picture definition is stored in memory area called the refresh buffer or frame buffer. This memory area holds a set of intensity values for all the screen points. Stored intensity values are then retrieved from the refresh buffer and painted on the screen one row, that is scan line at a time, as shown in the illustration. Each screen point is referred to as a pixel, that is picture element or PEL. At the end of each scan line, the electron beam returns to the left side of the screen to begin displaying the next scan line. Raster scan display. In this video, we are going to see about raster scan display. The electron beam is swept across the screen one row at a time from top to bottom. As it moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. This scanning process is called refreshing. Each complete scanning of a screen is normally called a frame. The refreshing rate, called the frame rate, is normally 60 to 80 frames per second, or described as 60 Hz to 80 Hz. Picture definition is stored in a memory area called the frame buffer. This frame buffer stores the intensity values for all the screen points. Each screen point is called a pixel, that is, picture element. On black and white systems, the frame buffer storing the values of the pixels is called a bitmap. Each entry in the bitmap is a 1-bit data which determine the on 1 and off 0 of the intensity of the pixel. On color system, the frame buffer storing the values of the pixels is called a pixmap, though nowadays many graphics libraries name it as bitmap 2. Each entry in the pixmap occupies a number of bits to represent the color of the pixel. For a true color display, the number of bits for each entry is 24, that is 8 bits per red or green or blue channel. Each channel, 28, is equal to 256 levels of intensity value, that is 256 voltage settings for each of the red or green or blue electron guns. Plasma display. In this video, we are going to see about plasma display. Plasma display. The plasma display contains a gas at lower pressure sandwiched between horizontal and vertical grids of fine wires. A lower voltage will not start a glow, but will maintain a glow once started. Normally, the wires have this low voltage between them. To see a pixel, the voltage is increased momentarily on the wires that intersect the desired point. To extinguish a pixel, the voltage on the corresponding wires is reduced until the glow cannot be maintained. Plasma displays can be AC or DC or hybrid, AC or DC activated. AC and DC plasma displays are shown in figure. The DC activated display consists of a dielectric spacer plate which contains the gas cavities sandwiched between plates containing the row column conductors. The electric field is applied directly to the gas. A DC activated plasma display requires continuous refreshing. In the AC activated plasma display, a dielectric layer is placed between the conductors and the gas. Thus, the only coupling between the gas and the conductors is capacitance. Hence, an AC voltage is required to dissociate the gas. The characteristic capacitive coupling provides enough voltage to maintain the activity in the corresponding pixels, but not enough to activate non-conducting pixels. A hybrid AC or DC plasma display uses DC voltage to prime the gas and make it more easily activated by the AC voltage. The principal advantages of the hybrid AC or DC plasma display are reduced driver circuitry. Liquid crystal display. In this video, we are going to see about liquid crystal display. Liquid crystal displays are the devices that produce a picture by passing polarized light from the surroundings or from an internal light source through a liquid crystal material that transmit the light. Liquid crystal displays, that is LCDs, are commonly used in small systems such as calculators and portable laptop computers. These non-emissive devices produce a picture by passing polarized light from the surroundings or from an internal light source through a liquid crystal material that can be aligned to either block or transmit the light. The term liquid crystal refers to the fact that these compounds have a crystalline arrangements of molecules, yet they flow like a liquid. Flat panel displays commonly use pneumatic, that is thread-like liquid crystal compounds that tend to keep the long axis of the rod-shaped molecules aligned. A flat panel display can then be constructed with a pneumatic liquid crystal, two glass plates each containing a light polarizer at right angles to the other plate sandwich the liquid crystal material. Rows of horizontal transparent conductors are built into one glass plate, and columns of vertical conductors are put into the other plate. The intersection of two conductors defines a pixel position. Normally, the molecules are aligned as shown in the on-state figure. Polarized light passing through the material is twisted so that it will pass through the opposite polarizer. The light is then reflected back to the viewer. To turn off the pixel, we apply a voltage to the two intersecting conductors to align the molecules so that the light is not twisted. This type of flat panel device is referred to as a passive matrix LCD. Picture definitions are stored in a refresh buffer, and the screen is refreshed at the rate of 60 frames per second, as in the emissive devices. Backlighting is also commonly applied using solid-state electronic devices so that the system is not completely dependent on outside light sources. Colors can be displayed by using different materials or dyes and by placing a triad of color pixels at each screen location. Another method for constructing LCDs is to place a transistor at each pixel location using thin film transistor technology. The transistors are used to control the voltage at pixel locations and to prevent charge from gradually leaking out of the liquid crystal cells. These devices are called active matrix displays. The light twisting, shutter effects are used in the design of most liquid crystal display devices. Advantages: does not rely on phosphorus. Easy disposal. Energy efficient, low power. Excellent contrast. Immune to screen image burn-in. Lightweight and compact. Flow flicker rates. Screens are available in a vast range of sizes. Disadvantages: features poor black on dark imagery. With brightness from backlighting, imagery may appear flat. Motion blur is common. Pixel-based display may be stuck on screen. Fixed resolution. Newer technology cost more. Imagery not as good with analog interface. Plotters. In this video we are going to see about plotters. A plotter is a printing device connected to a computer that operates by moving a pen to the surface of the paper. Plotters are typically wide printers designed to reproduce architectural drawings, maps, graphs, and diagrams on large sheets of paper. XY plotter. An XY plotter is a plotter that operates in two axes of motion, that is X and Y, in order to draw continuous vector graphics and a special mechanism to raise and lower the pen. The term was used to differentiate it from standard plotters, which had control only of the Y-axis and the X-axis being continuously fed to provide a plot of some variable with time. The plotter has a hole in its base where the pen goes through. It was designed to print on both paper and any surface such as a wall. Simply place the plotter against the surface and the pen will draw away through the hole. Roller plotter. A drum plotter is also known as a roller plotter. It also consists of mechanical device known as a robotic drawing arm that holds a set of colored ink pens or pencils. The robotic drawing arm moves side to side as the paper are rolled back and forth through the roller. In this way, a perfect graph or map is created on the paper. This work is done under the control of the computer. Drum plotters are used to produce continuous output such as billboards and maps. Printers. In this video, we are going to see about printers. What is printer? A printer is an electromechanical device which converts the text and graphical documents from electronic form to the physical form. They are the external peripheral devices which are connected with the computers or laptops through a cable or wirelessly to receive input data and print them on the papers. A wide range of printers is available with a variety of features ranging from printing black and white text documents to high-quality colored graphic images. Quality of printers is identified by its features like color quality, speed of printing, resolution, etc. Modern printers come with multi-purpose function, that is, they are combination of printer, scanner, photocopier, fax, etc. Uses of printers. Press. Printing machines are widely used in press to print news, advertisement, invitations, etc. Receipts. Printers are used in sales and money transaction where a receipt needs to be produced. Tickets. Printers are used to issue tickets in many places such as railways, buses, theaters, etc. Documents. Printers are used to print documents with images and ID proofs in offices and homes. In photo studios. Color printers are used in Photoshop to print photos. Types of printers. In this video, we are going to see about types of printers. Since the invention of the printing technology, a variety of technologies have been employed in computer printers. Printers are broadly categorized as impact printers, non-impact printers. Impact printers are classified into two types. They are character printers, line printers. Non-impact printers are classified into two types. They are inkjet printers, laser printer. Impact printer. An impact printer is a type of printer that operates by striking a metal or plastic head against an inked ribbon. The inked ribbon is pressed against the paper, marking the page with the appropriate character, dot, line or symbol. Print quality depends on the quality of the inked ribbon, but these printers are mainly used for printing backup copies of large amounts of data. Still, these printers are used in some law offices for letter quality printing, which are closely resembles like office typewriters, that is, except that they are controlled by the computer. Impact printers are classified into two types. They are character printers, line printers. Character printers. Character printers are printers which print one character at a time. Character printers are further divided into two types. They are dot matrix printer, daisy wheel printer. Dot matrix printer. Dot matrix printer is a popular computer printer that uses an array of metal pins aligned in a column, striking an ink ribbon positioned between the pins and the paper, creating dots on the paper. These combinations of dots from the desired shape on the paper. The speed of a dot matrix printer is measured by the number of characters per second. The speed of most dot matrix printers range from 200 to 400 characters per second, depending on desired print quality. The quality of print is determined by the number of pins used, that is, varying from 9 to 24. Daisy wheel printer. Daisy wheel printer uses a metal or plastic disc containing each of the letters, numbers, and other characters it supports. To print a character, the printer rotates the disc until the desired letter is facing the paper. Then, a hammer strikes the disc, forcing the character to hit an ink ribbon, leaving an impression of the character on the paper. These printers are generally used for word processing in offices with very nice quality representation. Line printers. Line printers are printers which print one line at a time. Line printers are further divided into two types. They are drum printer, chain printer. Drum printer. Drum printer is like a drum in shape, so it is called as drum printer. The surface of drum is divided into number of tracks. Total tracks are equal to size of paper. That is, for a paper width of 132 characters, drum will have 132 tracks. Chain printer. Chain printer is a chain of character sets are used, so it is called as chain printers. A standard character set may have 48, 64, 96 characters. Non-impact printers. In this video, we are going to see about non-impact printers. The printers that does not operate by striking a head against a ribbon. Non-impact printers are classified into two types. They are inkjet printer, laser printer. Inkjet printers. Inkjet printer is a type of computer printer that creates a digital image by propelling droplets of ink onto paper, plastic, or other substrates. Currently, most inkjet printers use either thermal inkjet or piezoelectric inkjet technology. Most inkjet manufacturers use this technology in consumer inkjet printers. Piezoelectric inkjet technology is used with all printers and industrial inkjet printers. Generally, monochrome, that is black and white printers, contains a black colored ink cartridge, and a color printer contains two cartridges, one with black ink and other with primary colors, that is cyan, magenta, and yellow. An inkjet printer can print 200 to several hundred papers depending on the nature of the hard copy before the ink cartridge need to be replaced. Laser printer. Laser printing is an electrostatic digital printing process that rapidly produces high-quality text and graphics on the paper. Laser printers are the most popular printers that are mainly used for large-scale qualitative printing. They are among the most popularly used fastest printer available in the market. A laser printer uses a slight different approach for printing. It does not use ink like inkjet printers. Instead, it uses a very fine powder known as toner. Most laser printers comes with a basic set of fonts called internal or resident fonts, but you can add additional fonts in one of two ways. Font cartridges, soft fonts, other types of printers, photo printer, dye sublimation printer, thermal printer, all-in-one printer, photo printer. A photo printer is an inkjet printer that produces images that copy the print resolution and the color range of prints from a photographic film. Nowadays, most photo printers are functioning independently without the need of a computer. Dye sublimation printer. A dye sublimation printer or dye sub printer is a computer printer which employs a printing process that uses heat to transfer dye onto materials such as a plastic, card, paper or fabric. The sublimation name was first applied because the dye was considered for transition between the solid and gas states without going through a liquid stage. Thermal printer. They are used in most of the handheld devices. More often, we can see in the bus conductor ticket system, credit card billing system. All-in-one printer. An all-in-one printer is a device made up of multiple peripheral functionalities and capabilities, including printing, copying, and scanning. All-in-one printers provide centralized document management for large and small enterprises. Principal operation of inkjet printer. In this video, we are going to see about principal operation of inkjet printer. An inkjet printer is any printer that places extremely small droplets of ink onto paper to create an image. A print head scans the page in horizontal strips using the printer's motor assembly to move it from left to right and back again, while the paper is rolled up in vertical steps again by the printer. A strip or row of the image is printed, then the paper moves on, ready for the next strip. For most inkjet printers, the print head takes about half a second to print a strip across the page. On a typical 8 2x2 inches wide page, the print head operating at 300 dpi deposits at least 2,475 dots across the page. This translates into an average response time of about 2 by 5,000th of a second. There are several types of inkjet printing. The most common is drop-on demand, that is DOD, which means squirting small droplets of ink onto paper through tiny nozzles, like turning a water hose on and off 5,000 times a second. Depending on the drop generation method, Three types of inkjet printers are used: continuous jet, intermittent jet, drops on demand. Principal operation of laser printer. In this video, we are going to see about principal operation of laser printer. Laser printing is an electrostatic digital printing process that rapidly produces high-quality text and graphics by passing a laser beam over a charged drum to define a differential charged image. The photoconductive drum is given a positive or negative charge by the charged corona wire. When the drum starts to revolve, a laser beam is shown on it. This laser beam consists of light photons. The laser assembly shines the laser beam on a mirror, which is then reflected off the mirror. As a result, the drum that is made up of photoconductive material is discharged. The areas of the drum that are touched by the laser develop charge that is opposite to the charge of the drum. The laser etches fixes and characters on the surface of the photoconductive drum. The fixes or characters are actually a pattern of electric charges. Thereafter, a fine ink powder called toner is sprinkled on the paper. This powder has to be positively charged. After this, the drum rolls over the paper. The paper passes along a belt under the drum. The paper is given a negative charge. This negative charge must be stronger than the charge of the laser-etched electric image. This will aid the toner to leave the negative area on the drum for the negatively charged paper. The paper is discharged as it moves out. This will prevent the paper from getting attached to the positively charged drum. The paper moves at the same speed as the drum. The paper is passed through a fuse. As the paper passes through a fuse, the toner melts due to heat. The tone is thus fixed on the paper. The fuser rolls out the paper to the output tray. The printing process of a laser printer is thus complete. Keyboard. In this video, we are going to see about keyboard. The keyboard looks like a typewriter. Most common and very popular input device is keyboard. The keyboard helps in inputting the data to the computer. Most of the keyboards have 80 to 110 keys. Key types: typing, alphanumeric keys, function keys, control keys, cursor keys. Typing, alphanumeric keys. The typing keys include the letters of the alphabet, generally laid out in the same pattern used for typewriters. These include same letter, number, punctuation and symbol keys. Function keys. Keys that act as shortcuts for performing certain functions such as saving files or printing data. Function keys usually are lined along the top of the keyboard, labeled F1 through F12. Control keys. Control keys are used alone or in combination with other keys to perform certain actions. The most using control keys are Insert, Home, Page Up, Page Down, End, Delete, Control, Windows logo. Some of the frequently used key combinations are Ctrl plus F4, Exit. Ctrl plus A, Select all. Ctrl plus C, Copy. Ctrl plus V, Paste. Ctrl plus B, Bold. Ctrl plus S, Save. Cursor keys. Cursor keys include a variety of keys which moves the cursor to different positions on the screen. Arrow keys are programmed to move the cursor in a specified direction. Page up and page down keys. Scroll the page up and down. The home key is used to return the cursor to the beginning of the line where the cursor is located. The end keys put the cursor at the end of the line. Keyboard types. Trackball. In this video, we are going to see about trackball. A trackball is a pointing device consisting of a ball held by a socket containing sensors to detect a rotation of the ball about two axes, like an upside-down mouse with an exposed protruding ball. The user rolls the ball with the thumb, fingers, or the palm of the hand to move a cursor. Large tracker balls are common on CAD workstations for easy precision. Before the advent of the touchpad, small trackballs were common on portable computers where there may be no desk space on which to run a mouse. Some small thumb balls clip onto the side of the keyboard and have integral buttons with the same function as mouse buttons. When mice still used as a mechanical design, that is with slotted chopper wheels interrupting a beam of light to measure rotation, trackballs had the advantage of being in contact with the user's hand, which is generally cleaner than the desk or mouse pad and doesn't drag it into the chopper wheels. The late 1990s replacement of mouse balls by direct optical tracking put drag balls at a disadvantage and forced them to retreat into inches where their distinctive merits remained more important. Most trackballs now have direct optical tracking, which follows dots on the ball. As with modern mice, most trackballs now have an auxiliary device primarily intended for scrolling. Some have a scroll wheel like most mice, but the most common type is a scroll ring which is spun around the ball. Kensington's slim blade trackball similarly tracks the ball itself in 3 dimensions for scrolling. Uses of trackball. Trackballs are used in a variety of fields, from air traffic controlling to operating equipment to drafting and design work. A lot of specialized work environments still use trackballs due to their precision. Advantages: direct tactile feedback, high resolution, allows rapid cursor positioning, can modify control display gain. Disadvantage: not well suited for drawing, no three-dimensional input. Joystick. In this video, we are going to see about joystick. A joystick is an input device consisting of a stick that pivots on a base and reports its angle or direction of the device it is controlling. A joystick, also known as a control column, is the principal control device in the cockpit of many civilian and military aircraft, either as a center stick or side stick. It often has supplementary switches to control various aspects of the aircraft's flight. Joysticks are often used to control video games and usually have one or more push buttons whose state can also be read by the computer. Joysticks are also used for controlling machines such as cranes, trucks, underwater unmanned vehicles, wheelchairs, surveillance cameras, and zero-turning radius lawn movers. Joystick elements: stick, base, trigger, extra buttons, auto fire switch, throttle, hat switch, that is POV hat, suction cup. Working of joystick. In this video, we are going to see about working of joystick. In order to communicate a full range of motion to the computer, a joystick needs to measure the stick's position on two axes: the x-axis, that is left to right, and the y-axis, that is up and down. Just as in basic geometry, the xy coordinates pinpoint the stick position exactly. In the standard joystick design, the handle moves a narrow rod that sits in two rotatable slotted shafts. Tilting the stick forward and backward pivots the y-axis shaft from side to side. Tilting it left to right pivots the x-axis shaft. When you move the stick diagonally, it pivots both shafts. Several springs center the stick when you let go of it. To determine the location of the stick, the joystick control system simply monitors the position of each shaft. Components of joystick. In this video, we are going to see about components of joystick. The various parts of the joystick are handle or top, stick or shaft, pivot, mounting plate, spring, resistor gate, wire harness, actuator, E-ring, stick or shaft, the rod in the joystick, handle or top, the held part at the top of the stick, which usually comes in two shapes: a ball top or teardrop or bat top, pivot. the area in which the shaft swivels. A part surrounding the shaft is usually placed here to assist in this. It comes in shapes like cylinders and half spheres set on a plate that is contoured for smooth movement. Spring. The mechanism most joysticks use for automatically resetting the shaft to neutral. Some joysticks use magnets for this. Thicker or larger springs makes the reset stronger and movements more effective. A part is often added to secure the spring below the pivot. Actuator. The actuators gives the bottom of the shaft more area and precision in pressing the switches. The actuator can refer to a shaped enhancement surrounding the bottom of the shaft or the levers on levered micro switches. E-ring. An E-ring, that is also called E-clip, is a small, flat, curved plate of metal shaped like the letter E. It is a type of retaining ring, also called a circlip or snap ring, which is a type of fastener. It attaches to the bottom of the shaft, aligning and securing the parts along it. This also puts some compression and tension in the spring, so the joystick has to return to its neutral position. It can be wedged off using a flat screwdriver or something similar and replaced using pliers. Another version is the C-ring. It pretty much needs to retain ring pliers, also called snap ring pliers, to remove and replace it. Other joysticks use a bolt or nut for the retaining function. Mounting plate. The plate of the joystick is attached directly and securely to the control panel. This and the dust washer are the only two parts of the joystick that need to touch the control panel. Guide or dust, washer or disc or cover. With many names, this flat disc surrounds the shaft on top of the control panel to hide and protect the insides of the joystick and the hole in the panel. It also works to enhance play when part of the hand rests on it. Restrictor gate. A restrictor gate is a plate with a specifically shaped hole, like a square or circle, that determines physically where the joystick can be moved. It is generally attached to the bottom of the joystick, restricting the bottom of the shaft. Many joysticks do not come with restrictive gates and are always circularly restricted. Wire harness. Some joysticks have the micro switches attached to a PCB into which a wire harness, that is, wires aligned along a plug, is inserted instead of having to wire each of the micro switches around the bottom of the joystick. Miscellaneous. Various joystick models and makers add various other parts to tweak and complete the joystick. They add things like screws, housing, extra spacers and scorers along the shaft, other plates for holding things like micro switches and the pivot and other pieces that tweak various components. Mouse. In this video we are going to see about mouse. The mouse is an input device that is control station for computers. The development of graphical user interfaces has made the computer mouse a standard input device. It is now practically available on any PC. The movement of the mouse run with the hand on the table or a suitable base, such as the mouse pad is received via a sensor in the mouse, digitized and transmitted via an interface to the connected computer. The mouse was invented by Douglas Engelbart in 1964 and consisted of a wooden shell, circuit board and two metal wheels that came into contact with the surface it was being used on. The first mouse, a bulky device, used two wheels perpendicular to each other. It was 8 years later, in 1972, that Bill English developed the design further by inventing what is known as the ball mouse that we know today. The ball replaced the wheels and was capable of monitoring movement in any direction. The ball came into contact with two rollers that in turn spun wheels with graduations on them that could be turned into electrical pulses representing direction and speed. At the time, Bill English was working for Xerox PAR, that is Palo Alto Research Center, the research and development center set up by Xerox to design the future of computing. The mouse became part of the groundbreaking Xerox Alto computer system, which was the first mini-computer system to offer a graphical user interface. An optical mouse was developed in around 1980, eliminating the ball, which often became dirty from rolling around the desktop, negatively affecting its operation. Today, the optical mouse has completely replaced the ball mouse being supplied as standard with all new computers. Operation of mouse. In this video, we are going to see about operation of mouse. The mouse operation function is to help us control the computer better and make it easy for us to access computer programs, documents, etc. The mouse is a pointing and a clicking device. The pointing is simply the X and Y location plotted on the screen or display. Items on the screen have functions built into them waiting for the mouse to interact with them. A click down on the button will start this process. Some web pages have JavaScript embedded in them to watch, listen for the mouse to move and click. The middle wheel of most of today's computer mouse is designed to scroll or zoom. Mouse is a pointing device which contains an optical sensor in its base. There are 5 basic computer mouse operations: left button, right button, scroll wheel, navigation control, connectivity, single click to select the object, double click to open the selected object. The left mouse button allows for the selection of and interaction with programs, internet web pages, and other computer functions. By clicking this button twice while hovering over program icons or double-clicking the mouse instructs the computer to open the program. By hovering over an icon or other item, and depressing the button once and holding it, the user can move or drag the item to a different location on the screen. In a text program, depressing this button and dragging it across individual words or entire lines of text highlights the selection, allowing for editing. The right mouse button is used for accessing specialized context-sensitive menu options for the particular program or screen on which you click it. This allows you quick access to various actions without having to search for them in the toolbar at the top of the screen. If you click the right button on a text document, for instance, a menu appears allowing you to change the various properties within the document, such as the font style or size. Right-clicking on a web page allows you to save or print the page. Single-click only to select the icon. The pop-up window appears with its properties. Scroll wheel. Many computer mice are equipped with a scroll wheel nestled between the left and right buttons, which allows you to move the screen up and down quickly. Normally, the mouse cursor stops as it comes to the top or bottom edge of a screen, requiring you to move to the scroll bar located on the right-hand side of the screen to physically move the screen up or down using the left mouse button. The scroll wheel allows you to keep the mouse stationary and still move your cursor on the page. Navigation control. The bottom of the mouse offers the navigation control, which moves the cursor around the screen and allows you to select and interact with items. This navigation control is typically available in two styles, as a hard rubber trackball or an optical laser. Both perform the same action by recording the movement of the mouse as you slide it across your desk or mousepad and transferring it to the cursor on the screen. Connectivity. Most computer mice connect to the computer via a cable that connects to the back of the tower. While this typically allows for quick and easy setup, the cable could become burdensome by snagging on objects or getting tangled with all the other cables that computers require. To combat this, wireless mice are available which use infrared signals to communicate with the computer. This allows the user for complete motion and use of the mouse without the restrictive tendencies of a connected cable. Types of mouse. In this video, we are going to see about types of mouse. There are different types of computer mouse available, such as mechanical mouse, optical mouse, laser mouse, trackball mouse. Mechanical mouse. A mechanical mouse is a computer mouse that contains a metal or rubber ball on its underside. When the ball is rolled in any direction, sensors inside the mouse detect this motion and move the on-screen mouse pointer in the same direction. Optical mouse. An optical mouse is an advanced computer pointing device that uses a light-emitting diode, that is LED, an optical sensor and digital signal processing, that is DSP, in place of the traditional mouse ball and electromechanical transducer. Laser mouse. A laser mouse is a type of optical mouse that uses laser light to detect mouse movement. Like all optical mouse, the laser mouse has no moving parts inside. A laser is more accurate than the standard optical mouse design, providing for up to 20 into greater sensitivity and precision. This improved sensitivity and precision can be a key for gaming applications and graphical or engineering design applications where pinpoint accuracy is important. Trackball mouse. A trackball is a pointing device consisting of a ball held by a socket containing sensors to detect the rotation of the ball about two axes, like an upside-down mouse with an exposed protruding ball. The user rolls the ball with a thumb, fingers, or the palm of the hand to move a pointer. Light pen. In this video, we are going to see about light pen. A light pen is a pointing device shaped like a pen, acts as computer input device. The tip of the light pen containing a light-sensitive element which, when placed against the screen, detects the light from the screen, enabling the computer to identify the location of the pen on the screen. Light pens have the advantages of drawing directly onto the screen. It allows the user to point to displayed objects or draw on the screen in a similar way to a touch screen but with greater positional accuracy. A light pen can work any CRT-based monitor, but not with LCD screens, projectors or other display devices. The light pen consists of a photoelectric cell housed in a pen-like case. It works by sensing the sudden small change in brightness of a point on the screen when the electron gun refreshes that spot. By noting exactly where the scanning has reached at that moment, the XY position of the pen can be resolved. This is usually achieved by the light pen causing an interrupt, at which point the scan position can be read from a special register or computed from a counter or time. The pen position is updated on every refresh of the screen. The response time of the pen is also important. For slow displays transistor type, photocells such as photodiodes are used. These are small, inexpensive and suitable for handheld operation. The response time is about 1 microsecond. For the high-speed displays, photomultiplier tube is used. It is bulky and uses fiber optic cable. Nowadays, improved light pens are available. These consist of a matrix of the fiber optic sensor. Advantages: direct eye-hand coordination, inexpensive models available, no extra space required, disadvantages: arm fatigue, arm and light pen obscure display, user must be close to display. Tablet and digitizing camera. In this video, we are going to see about tablet. Tablet. For applications such as tracing, we need a device called a digitizer or a graphical tablet. It consists of a flat surface ranging in size from about 6 by 6 inches up to 48 by 72 inches or more, which can detect the position of a movable stylus. Different graphics tablets use different techniques for measuring position, but they all resolve the position into a horizontal and a vertical direction which correspond to the axis of the display. Most graphics tablets use an electrical sensing mechanism to determine the position of the stylus. In one such arrangement, a grid of wire on 1 by 4 to 1 by 2 inch centers is embedded in the tablet surface. Electromagnetic signals generated by electrical pulses applied in sequence to the wires in the grid induce an electrical signal in a wire coil in the stylus. The strength of the signal induced by each pulse is used to determine the position of the stylus. The signal strength is also used to determine roughly how far the stylus or cursor is from the graphical tablet. Every time user may not wish to enter stylus position into the computer. In such cases, user can lift the stylus or make the tablet off by pressing a switch provided on the stylus. Other graphical tablet technologies use sound, that is sonic coupling and resistive coupling. The sonic tablet uses sound waves to couple the stylus to microphones positioned on the periphery of the digitizing area. The sound bursts are created by an electrical spark at the tip of the stylus. The time between when the spark occurs and when its sound arrives at each microphone is proportional to the distance from the stylus to each microphone. The sonic tablets mainly used in 3D positioning the devices. The resistive tablet uses a battery-powered stylus that emit high-frequency radio signals. The tablet is a piece of glass coated with a thin layer of conducting material in which an electrical potential is induced by the radio signals. The strength of the signals at the edges of the tablet is inversely proportional to the distance to the stylus and can thus be used to calculate the stylus position. Digitizing camera. Digital camera capture images electronically, unlike the normal film cameras which capture images on a specially coated film. The digital camera digitizes the image, compresses it and stores it on a special memory card. The user can copy the information to a PC. The digital images can be transmitted from digital camera to a computer using standard cables, disk, or infrared networking. The captured image can be edited, copied, printed, embedded in a document, or transmitted to another PC. Their working is same as PC video cameras, except that they capture still images and they are handy and portable. Most digital cameras can store dozens of high-resolution images at a time. This memory capacity can be increased further. The digital cameras are available in different ranges from inexpensive home use model costing just over $100 to professional versions costing several $1,000s. Operating principle. In traditional cameras, films are used to capture images. Digital cameras use an array of optical sensors to capture images. These sensors are nothing but the devices such as photodiodes which convert light into electric charge. These are two types of sensors which are generally used in commercial products: charge-coupled devices, that is CCDs, and CMOS technology-based sensors. CCDs give higher quality images than sensors based on CMOS technology, but they are more expensive than CMOS-based sensors. Lens assembly. The lens assembly consists of zoom and focusing lens. Optical sensors. These are sensing elements which generate charges. Each sensing element generates a charge that corresponds to 1 pixel. Pixel is one point of pictorial images. The number of pixels determines the quality of pictures. Analog to digital converter, that is ADC. The charge is an analog quality. This is converted into digital representation using ADC. The digital representation of the image is nothing but the color and intensity of each pixel represented by a number of bits. System controller. This block consists of a processor, memory, that is RAM, EEPROM, and interface circuits required to connect to other parts of the system. The processor controls the operation of the camera. The image data obtained from ADC is processed by the processor to obtain images representation in standard formats suitable for use in computers, printers, display devices, etc. TIFF, that is tagged image file format, is widely encountered by uncompressed, and JPEG, that is Joint Photographic Experts Group, for compressed images. Image storage. The processed images are stored in storage devices such as flash memory cards, floppy disk, miniature hard disk drives, etc. Liquid crystal display, that is LCD. The captured and processed image can be displayed on an LCD screen. Interface. A standard interface provides a simple mechanism for transferring the images to a computer or a printer. A simple serial or parallel interface or a connector for a standard bus such as PCI or USB can be used. Images can also be transferred by physically transferring the card if flash memory cards are used. Input switches, motor and the flash unit. The motor is used for focusing purposes and the system controller generates the signals needed to control the operation of the motor and the flash unit. Some of the inputs come from switches which are activated by the user. Design. The processor used in digital camera has to perform quite complex signal processing functions. Therefore, a digital camera requires a considerably more powerful processor than needed for microwave oven. The camera is a battery-operated device, so the processor should not consume much power. The processor consumes less power than the display and flash units of a camera.